In this video, we're going to set up a small VDB that's based on the inside of our body, and wherever the body penetrates itself, it's going to create a little crevice where the cloth can safely simulate. We go to our file here. Let's go ahead and take a look at our geometry spreadsheet in points, and you can see here that we don't have a normals attribute, even though the peak seems to be working off that. I don't have ability to actually look at that, so I'm going to add a normals node here for points because I'm going to be moving points along their normal. So instead of vertices, points. So now we can see a normals attribute is here. Next, we're going to go ahead and add the VDB, or I'm sorry, a point wrangle. Whoops. And this is where we're going to do a lot of our math here. Okay, inside of this point wrangle, we're going to sample a VDB data that's coming in through the second input. So let's go ahead and add a VDB. And this is going to be a VDB from polygons. So VDB from polygons. Okay, we'll go ahead and sample that there. And let's pick a frame where there's a considerable amount of penetration going on. I think somewhere in the 1160s is probably pretty good. So go there. Yep, this is sort of, we'll just take a look at it here. And there is a little bit in the leg here as well as in the arm. So we can go ahead and check that out. So let's go back to our VDB here. These cells are far too large. So what we want to do is reduce by a factor of 10, but every time you do this, it gets exponentially slower. So you only want to reduce it as much as you absolutely have to. In my tests, I came up with a number of 0.001, and you can see that looks pretty good. It starts to represent the actual surface of the mesh. Again, you don't want to go too low on these voxel size, or else it'll start to increase exponentially, just as many voxels as you need. So let's take the output of that and put it in this point wrangle. Conceptually, we're going to be looking at the surface of our geometry. And every point on our geometry, we're going to sample a slight position right above the surface. And if this point is in a volume and it has samples with a negative value, then we know that it's inside and it's penetrating the geometry. If it comes back with a positive value, then it's probably just floating out in space and it's not penetrating. So let's go ahead and do this inside of Houdini. In your point wrangle attribute, let's go ahead and create a vector attribute. We'll call this vector above the surface, and this is going to be equal to our current position plus a certain vector, which is going to be our normal times some threshold we haven't defined yet. So we'll say channel, we'll just generate that now, threshold. Let's go ahead and create that threshold now. It's a floating value. We'll just give it a value of 0.0, well, just 0.1 at the moment. We'll just give it that. And then we're going to sample the volume that's coming in through input 1. So we're going to give that a value. I want to be able to see that in the geometry spreadsheet, so we'll go down here and we'll call it a float value called phi. Phi is the name of the value that is used in terms of level set volumes and sine distance functions. So we're going to call it that. And I'm going to do a volume sample. Okay. And we're going to take the second set here. So we're going to do our geometry input, and that'll be the first one. And then the volume name. The volume name is actually 0. And then we're going to pick the position that we just defined. So we're going to say the volume coming in through there, its name is 0, and the position above. And that's going to be our phi value. If phi, and I know I don't have to put the float value, the f inside, but I just like to practice. Okay, so I'm not in Python, so I got to make sure I put these parens around here. If it's lower than 0.00, we're going to do something. We're going to modify our position in space. So we're going to say position, our current position of that point. We're going to push it along the normal. We're going to push it in, so we're going to say minus equals. And we're going to do that based on our normal. So at normal times a channel offset. So a value like a slider we want to do. So we'll say channel float. We're going to call it offset. And then that is multiplied times the phi value. But it can't just be the phi value, because if the phi value is negative, then it's actually going to make it go positive. So we'll take the absolute value of our phi value, and that plus 1, because we're making a multiplier, so we're going to have to add it to 1, right? So this is our multiplier right here. We'll put that all in parens like this, so this is all just clear that this is all part of one thing. And that multiplied by our normal, this should work. Let's go ahead and check it. Okay. So we have to generate our offset, and let's just see if we're moving things. Yep, so things are moving based on their penetration. We just have to dial in these numbers a little bit until we get what we're looking for. So I can, just by dialing in this thing a little bit, I can see kind of where I'm at. And I don't want this to actually happen in the hands or the face. So once again, we're going to limit this to the body group. So just the body group. So this actually looks okay, pretty decent. Let's go ahead and set up with these values for now. Let's see, an offset of 0.01 is what I have in my notes. And then we'll do a 0.025 over here for threshold 25. Okay, this is pretty good. Yeah, they're splitting out pretty well. And once we have them smoothed, then they will actually look a lot better. So let's go ahead and speed this up. In order to flag which of these points needs to be smoothed or not, we're actually going to have to flag them. So let's create a default one, a default attribute called fValue, or just val. We're just going to set it to 0 by default, 0.0. And if this point has moved, then I'm going to put you a float value of f1. F at val is equal to 1.0. Now that we have these values, we can smooth this on the other side using our friend the group expand. So let's drop a group expand. And we're going to pick points. This is the output name. Let's see, the input name we're going to use in a little expression. We'll say at val is greater than 0.5, just so we know that it's either on or off. We don't need that. Okay, so everything in that group we're going to expand, and it's going to be points. Let's expand by, say, maybe a level of 2 for right now. So any of these points, I want them to get smoothed. So I'm going to grab a smooth node, but smooth nodes only work with primitive groups. So I'm going to have to do a group promote. And I'm going to promote my current group, which I'm calling expand. Let's see, my current group name is called expand 1. And I'm going to call it, let's call it smooth prims. So we'll call it smooth prims. And it's going to convert from points to primitives. There we go. So now I have a primitive group, and now I can do a smooth node. All right, let's pull this in. Okay, and that group coming in is going to be smooth prims. And you can see that's by default, that's what it looks like. Let's go ahead and maybe dial it up a little bit more. See what it looks like. Smoothing it up. Okay, that looks okay. I like to dial it up too. It's working. You can see it on the side here. So we can always adjust these values later as we deem fit. That doesn't look like there's a lot of space right there. So let's go back and play with our threshold value. So let's see, I think offset is the value that's moving it. So let's see if we can push it out a little bit further. There we go. Let's see. Yeah, that looks pretty good. Maybe, let's see, I got these wrong. That's why. And this is 0.001. There we go. That's what was in my notes. So this gives a much better area. Later on when we're simming, this area right here can get problematic. I'll talk about when we get into simulation how we can possibly, oh, and that looks horrible right there. That's bad enveloping altogether. So what we will do is we're going to find a way to use the soft transform to kind of push this belly back and maybe put these bodies in here. Actually, it doesn't look like it's actually bad enveloping. I went back and looked at this. It's actually the point deformer node. Our point deformer node has a very large radius, so you can start to lower that radius down a little bit. And you should see these points come back into spot. Yeah, there we go. So not a radius of that, but 0.01 or something like that. Because we know the points are right on top of each other when they were instantiated. So we can do a 0.1, just create a real small difference between them. Yeah, you can't really see any difference here, but that is not bad enveloping. That was, the radius was so large, it was points over here, we're getting points over here. One thing that you want to do, you're going to want to probably include the sword in this. So I'm going to go ahead and just insert this so that the big collision part also gets a VDB. So right before this, I'm going, right after the peak, but before the normal, I'm going to control drag everything down here and just add the merge. So I can merge in my geometry. for my sword, my collision sword. So I'm just going to drag that over and put it in. Give me a little error here, so we'll just add a convert node here. Convert, plop it in. Now, in order to get this to work, we need to include the sword. Right now, the sword is not in the body group, right? So in this point wrangle, I'm only doing it to body group. One thing I like to do in my process here is use a point wrangle and just define everything. So let's go ahead and do that right now. PW, point wrangle. And in this point wrangle, we're going to do two things. And we're going to do this for every single object in our process here. We're going to define two things. A collision group that's a string. And this one will be called sword. Just keep it simple. And I also like to include an integer, which is integer at sword, whatever the attribute of the basic description of the item, and I'm just going to equal it to 1. So I'm going to do this also for the body. So along the way down here, right before we go into the point deform, I'm going to do another PW wrangle. And in this point wrangle, I'm going to define a string that is a collision group. And this collision group will be body. We can change this to be various things like hands, head, etc. as you want. You can define that by groups however you want. So do the I at int body is equal to 1. We can refine that later if we need to. So as we come down here, I now have attributes that describe what these two chunks are. And when I come down to this point wrangle, I'm going to include the body group as well as anything that's sword. Sword is greater than 0.5, and that will help carve the sword too, so it'll help push the sword geometry in. We'll go down to this now and smooth. That's quite a bit of smooth. We might dial that depending on how we are. I think that's a little excessive there. Maybe dial it back to about 25. Let's do that. We can always come back to this later. The next thing you want to do is add a point velocity node. Point velocity. This will store the velocity of each point as a point value on every point in your collision object. This will be useful later if you decide to use a reference node, a vellum reference node, to help compensate for fast-moving objects. After that, we want to add a cache node. Not a cache node, but a file cache. File cache node. And this way we can store the results of all of our calculations so we don't have to redo them while we're simming. We're going to put this inside of a collisions folder. So the cache, the BGO cache is inside of a collisions folder. And we're going to rename this node. So we're going to just leave it OS, which means what it's named, and a version. We're going to start with version 1. And we're going to rename this to collisions, or let's say cache underscore collision body. And after that, we're going to add a null. This will be our out for this particular chain of events. So rename it out collision geometry. And color, press C, press the color black, and then press C again. Now let's go ahead and create this cache. So with everything set up here, let's save our node, file save, which I have as version 3. Make sure you're in the scenes directory, version 3. I'm going to accept, overwrite the one I just did. And I'm going to save to disk in background. Now what this does is it takes a copy of your HIP file, opens it up in a Python subprocess, and runs whatever action is part of this cache node. So it's going to assume that you want it to perform and store all the data coming down for every frame. And what we can do is we can open up the scheduler. So the render schedule paneler, if you don't open it here, you can close this. You can always hit the plus button here, new render type, and render scheduler. And in here you'll see a job that tells you approximately what percentage it's running. This is very useful. We're going to be doing this also for Vellum Sim, so we can keep building our Vellum setup while we're running test sims. So this is something I will go over again and again and again. So don't worry if you didn't pick it up this time. After you've sent this off as a render job, be sure and turn on load from disk and save your file that way. If you forget to do this, your sims will take a really long time and you'll think it's the Vellum solver, but actually it's spending a lot of time calculating these volume penetrations. So we want to make sure we turn that on at this time, okay? Very important. And then save your file that way. One last thing before I wrap up this video, there will be some adjustments made to this collision body as we process through our setup here. And mainly I will see that the abdominal section and the upper thighs will be pushed away from each other because there's a lot of geometry here between the belts, the top coat, the undershirt, and the cloak will get caught in here. So we don't want any sizzling, so you won't see it. So we might as well push these in, but we're not going to do that until we actually get to that spot. In the next video, we will talk about how to set up the boots as a collision object by remeshing them to get rid of some of the more detailed pieces of geometry on there.